Hey little homies, it's Mr. Siegel here to talk about inscribed angles. Now, before we get started, I think it'd be probably good to know what is an inscribed angle. So let's talk a little bit about that. By definition, an inscribed angle is an angle whose vertex, you remember that's where the two lines meet? The vertex is on the circle. So angle C is an inscribed angle because its vertex is on the circle. Also, its two sides are chords. And if we look, its two sides are chords AC and chords CB. So once again, an inscribed angle is just an angle whose vertex is on the circle. Now if we look down, let's just go through these. If you look at this, this would be an inscribed angle. Its vertex is B and it's on the circle. AB and BC are the chords, and additionally, when you have chords that intersect a circle, it creates a chord, and that chord would be called chord ADC. Let's get these definitions on paper. If you could just write these down, what an inscribed angle is. An inscribed angle, as I said, is an angle whose vertex is on, not off, but on the circle, whose sides contain chords of the circle. And the intercepted arc, that's a new definition. The intercepted arc is what's created by those two chords. So this would be the intercepted arc. Because here are my two chords, they make this intercepted arc. And the arc that is on the interior of the inscribed angle and whose endpoints are on the angle. So let's take a look here. Let's draw some examples. Now I'm just going to draw three examples. Maybe you could draw your own if you want, or you can follow along. What would be inscribed angles? Well, let's look at this one. This is a circle, poorly drawn of course, and we're going to draw two chords that meet this angle. And this would be an example of an inscribed angle. It's an inscribed angle because, look, it has an angle who's on the vertex. That would meet the definition of an inscribed angle. Let's try another one. Let's make a vertex right here. Let's do some really wide lines. And once again, this would be an inscribed angle. Its vertex is on the circle, and it has two chords for its sides. Let's try one more and draw it yourself, or you can follow along. This really skinny one is once again an inscribed angle, because if you look at it right here, yes, its angle is on the circle and has two sides that are chords. But more importantly, let's look at non-examples. What would they not be? Well, let's try this one. Over here, we have a circle. If I were to draw this, would this be an inscribed angle? Nope. Why? Because its vertex is not on the circle. This would be a central angle, if you remember that. Remember, it's where the vertex is at the center, but it's not an inscribed angle. Would this be an inscribed? No, because its vertex isn't on the outside. You know what? Why don't you draw your own right here? You do it. I believe in you. All right, let's keep going. Right now, we're just going to work on naming the inscribed angle and its intercepted arc for the following circles. Well, the inscribed angle here. The inscribed angle would be right here, right? This would be our inscribed angle, angle B. So we just have to say our inscribed angle is angle B. That's the angle on the vertex. What's the intercepted arc? The intercepted arc is this guy right here, right over here. This is what our intercepted arc is. So our intercepted arc would be arc AC. Try the second one. If we move down, the inscribed angle, well, the vertex is right here, so that's angle E. So our inscribed angle would be E, right over our mia. And our intercepted arc would be this part, from D all the way to F. Remember, that's what our intercepted arc would be. So we'll just write DF, arc DF. All right, I think we got the definitions down. Let's look at some facts about that. Here's fact number one. There's two facts we're going to learn. This is the first one. The measure of an intercepted arc remember, this is our intercepted arc. The measure of our intercepted arc is equal to twice the measure of the inscribed angle. It's times 2. So if this angle right here is 50 degrees, that's our inscribed angle. Our arc is twice that amount, or double. So our arc would be 100 degrees. You got that? The arc is twice the angle. The formula could be right here. The intercepted arc is equal to 2 times the inscribed angle. So let's look at this guy right here. We are trying to find the arc, which is x. We know the inscribed angle is equal to 18 degrees. If I want to find the arc, what do? Well, to find the arc, the intercepted arc, I'll just do 2 times the inscribed angle. And what's our angle in this case? 18 degrees. So the arc, our intercepted arc, would just be equal to 36 degrees. Or x equals 36. Weep! That's it. We know this arc is 36 degrees. From here to here would be a 36-degree arc. Let's look at the second one. Once again, we know that our inscribed angle is 103 degrees. To find out what the arc is, that's this whole thing right here, to find x, we just know that x, which is our arc, is equal to 2 times the inscribed angle. So if we double our inscribed angle, 2 times 103 would be 206 degrees. So our intercepted arc is equal to 206. Pretty straightforward, right? You just double what your inscribed angle is, and that will tell you what your intercepted arc is. Let's look at the opposite of that. The measure of the inscribed angle is equal to half the measure of the intercepted arc, which is just basically the opposite. So if I know what this arc is, let's say I knew the arc was 100. If I know this arc is 100, the inscribed angle is half of that, which would just be 50. So it's just like the opposite of what we just did. So the inscribed angle is equal to half the intercepted arc. So let's take a look at these examples. This example says our arc is 210 degrees. We want to find x, which is our inscribed angle. So since x is our inscribed angle, to find x degrees, we'll just do 210, which is our intercepted arc, divided by 2. So x is going to be equal to 105. That's it. So x equals 105 degrees. Going down, let's take a look at this guy. Once again, we want to find what x is, which is our inscribed angle. It's going to be half of this arc. So to find our inscribed angle, we take our intercepted arc, which is 82 degrees, and we divide it by 2. And so x is going to equal 41 degrees. And that's this theorem. Now, we're not done yet. Let's take a look at 3 challenging problems and how we do them. Well, the first one, let's look at this. We're going to use a little knowledge from before. Now, we want to find out in this question the measure of arc DC. That's this guy right here. Now, if you notice, the 2 chords that intercept this arc are this and this, right? So to find what DC is, I need to find out what the inscribed angle is, which is this, right? The 2 sides create this arc. And if I can know what this angle is, I can find out what the arc is. Well, how can I find out what this angle is? Well, luckily enough, this is a triangle, right? Since this is a triangle, to find the third missing side, I do as we've always been doing. 180 minus 49 minus 70. If we do that, let's see, that's 119, so that would be 61 degrees. So we know B, angle B, which is our inscribed angle, is 61 degrees. Alright, now what do we do with that? Well, if I know that B is 61 degrees, and I want to find out what the whole arc is, if you remember the formula, just remember that the interceptor arc is double whatever the inscribed angle is. So if I want to find the arc, the measure of DC, okay, all I have to do is take 61, 2 times 61 degrees. And so the measure of this whole arc, measure of DC, is going to be equal to 121 degrees. And that's all you have to do. You find the angle, and the arc is double that. You have to do a little creative thinking on here, but once you get this inscribed angle, you can get the whole arc. Alright, let's move down. Let's take a look at this one. Once again, a tricky problem. What we know in this one is this is what it's giving us. We're trying to find the measure of angle LMK. LMK is this. LMK. That's right here. To find out this angle, I would have to know what this arc is. So the first step in solving this problem is going to find out what is arc LK. Well, what information is given? Let's start there. To find out LK, this is what I can use. I know that this arc right here, LM, is 130 degrees. So from here to here, this guy is 130. And I know that MK from here to here is 160. To find out the missing part, if you remember, all three arcs are always going to add up to 360 because it's a circle. So I would just have to do 360 minus 160 minus 130. And if I do that, I get that that remaining arc is equal to, well, let's see, let's do some math. 200 minus 130, so that gives us a grand total of 70 degrees. So this arc LK is 70 degrees right here. That's the remainder. Okay, so this is 70 degrees. To find the inscribed angle, remember, it's just half of the arc. So to find out what the measure of angle LMK is, I just take the arc, which is 70 degrees, and I divide it by 2. So the measure of angle LMK will be equal to 35 degrees. And that's it. Alright, let's take a look at our third challenge problem. We want to find the value of x. Now, this one, we know our inscribed angle is 3x plus 3, and we know our exterior angle is 192. So here's what we could do. Remember, the formula for this, we could say that to find, okay, sorry, I got it, I've got this. Okay, we know that this angle, the inscribed angle, times 2 is going to equal the intercepted arc. So remember that. To find the arc, if you remember the arc formula, we could say the arc is equal to 2 times the angle, right? That's the formula we learned. Well, our arc is 192 degrees. Okay? And our angle is going to be equal to 31x plus 3. So all I did is substituted in what the angle was and what the arc is. Now I just solve this equation. Is 192 equals, well, we have to distribute this. We get 62x plus 6. We subtract 6 from both sides, and we get 62x equals 184. 186, sorry. And to solve, we divide both sides by 62. Divide by 62, and we get x equals 3. That's it. So those are your 3 challenge problems. Just remember, the arc length, our arc, is always equal to double the inscribed.